Okay, and here is your video on how you solve a molar solution using the metacognitive method. Here's the sample problem we're going to be solving. Calculate in milligrams how much magnesium oxide is needed to make 3.4 milliliters of 2.7 molar magnesium oxide. Record your answer to 3 decimals. As with all base math problems, we're going to start with step 1 of the metacognitive method, which is it a solution or a dilution? Because we have, again, 2 numbers in the problem, it is a solution. The second step of the metacognitive method is, well, what type of solution? And as always, to do that, we will look at the concentration unit. And we see here, we have a capital M, which stands for moles. So this is a molar solution. Now keep in mind, it could be a capital M, it could be a millimole, it could be a micromole, it could even be a kilomole. But if it's a mole, then it's a mole. Probably didn't need to say that last one. This third step of the metacognitive method is, what is the equation to solve a molar solution? And again, you have to memorize these, and that is total volume times concentration times molar mass is equal to the amount of solute needed. Step 4, we plug in the variables. What are the variables needed for this? All right, well, total volume is 3.4 milliliters. Concentration is 2.7 moles, but this is critical. Remember, whenever you get a molar concentration, you need to write it in as per liter. So I know the problem says 2.7 moles. What that really means is it's 2.7 moles per liter. And in fact, all of these are per liter. It doesn't matter what the prefix on the mole is, they're always per liter. Now, this brings us to the third part of this equation, which is the molar mass. Now, we only had 2 numbers, and yet this equation has 3 variables, and that's because you will be calculating the molar mass using the periodic table. So, the solute that we're working with is magnesium oxide. So, on the periodic table, here is magnesium. Make sure you check your periodic table's key to make sure you're looking at the right number. So you can see here, the number directly under the name is the atomic weight. That is the number we want. This ionization, ground state configuration, atomic number, all of those other numbers we do not care. We want the atomic weight. So for magnesium, the atomic weight is 24.3050. And that is in AMU. So that's the magnesium, and there's only 1 magnesium, so that's all I need to do. Now I have 2 oxygens in magnesium oxide, so the next thing I look up is oxygen, and I see that its atomic number is 15.999. But I need to multiply this by 2 because there are 2 oxygens in my magnesium oxide. So 15.999 times 2 gives me 31.998, and then I will add to it my magnesium oxide, my magnesium for the total molecular weight. So to that 31.998, I'm going to add 24.3050, the weight of the magnesium atom by itself, and I get that my total molecular weight is 56.303 atomic mass units, or AMUs. So the final thing I need to do before I plug this in is, because this is moles, I get to convert AMUs to grams. Simple as that. That's the magic of moles. The weight of an individual compound is the same as a mole of that compound when weighed in grams. If you don't understand that, that's fine. You don't have to. Just accept it. So our third variable, the molar mass, is the atomic mass, but instead of being in AMUs, it's just in grams. All right, the fifth step of the metacognitive method is, do I need to make any metric conversions? So I will check. My milliliter does not match my liter. Therefore, yes, I do need to make a conversion. I will be converting this 3.4 milliliters into liters. So here's my millifinger, here's my liter finger. I will be moving my decimal 3 places to the left. 1, 2, 3. I will then fill those loop-de-loops with zeros. So I now have 0.0034 liters times 2.7 moles per liters times 56.303 grams is equal to my solute. Kind of running out of room on that paper there. Which brings me to step 6. Solve. So my liters now match. I can cancel them out. So 0.0034 times 2.7 times 56.303 gives me this number. And no, I don't get to simplify it. I need to write the whole thing out. 0.51686.154. Now the question is, what is my units? You can see because my liters are gone, I'm left with moles and grams. My answer is in grams. You may be asking, Miss Barker, why is it not moles per grams? Because that's not how it works. Moles are measured in grams. So this is, it's in grams. Moles are measured in grams. They're not measured per liter. Now, the final step. I'm now going to reread the problem, looking for the unit and the decimal. They want the answer in milligrams, and they want it to 3 decimals. This is currently in grams, so I will convert it, grams to milligrams, so I will move my decimal 3 places to the right. 1, 2, 3. Which gives me the answer. Whoops. Milligrams, because I've converted it. And they want it to 3 decimals. So that's 1, 2, 3. I look at the number behind the 1, which is a 5. So I see I round up. So my final answer is 516.862 milligrams. And that is how you solve a molar solution.